Okay, in 4.3, we go back and look at sine, cosine, and tangent, and their inverses, cosecant, secant, cotangent, as related to the right triangle trig that hopefully you remember a little bit of from geometry. And I don't know how much you got into it last year in Algebra 2 trig at the end of the year when we were out. But we're going to look at basic trig, looking at how to find missing sides and angles of a right triangle, either using Pythagorean theorem or trig ratios. Look at special right triangles, cofunction identities. That sounds horrible, but it's really easy. And then a few word problems at the end. You have a 4.3 math lab if you'd rather do that than doing a book assignment. But if you need me to give you a book assignment, I can do that. So just let me know. Do all of you have computers now? Can y'all get in the Schoology or no? Okay. All right. I know that I didn't choose to get a new laptop because a lot of teachers were having issues with the new ones. Okay, remember, recall SOHCAHTOA? The first thing we're going to look at is just how you determine the basic ratios in order to set up future problems. So let's look at angle theta. And if we want to find all 6 trig values of angle theta, can you mind telling me what the inverse of sine is? What trig function is the inverse of sine? Close, cosecant. Cosecant is the inverse of sine. Secant is the inverse of cosine. And what is tangent's inverse? Cotangent. Okay, the sine of any angle is, notice that you've got these two sides that form the angle, C and B, but side C is your hypotenuse. So that means B would be your adjacent side. And A is not touching angle theta, so that's your opposite side. So sine is opposite side over your hypotenuse. Cosine of theta is your adjacent side over your hypotenuse, so it would be B over C. Tangent of theta, that's your opposite side over your adjacent side. So opposite is A, adjacent is B. Notice for sine, cosine, and tangent of theta, A over B is what tangent is, and that will always be the case. As long as sine and cosine have the same denominator, you can just take their numerators and make tangent. Cosecant, secant, cotangent. So once you know sine, all you have to do is flip it to get your cosecant. So C over A. Secant is cosine flipped, C over B. And cotangent is tangent flipped. Okay, you have the first problems in your math lab are going to ask you to find the missing side, then find all 6 trig values for a given angle. So we're trying to find this missing side. If you know 2 sides of a right triangle, what do you use to find the third side? Hey, Josh. There you go. Pythagorean theorem. What always gets plugged in for C? Hypotenuse. So square 40, square 41, and then subtract. So the missing side is what? 9. Okay, now that we know the missing side, we can find all 6 trig values for theta. What is the sine of theta? Opposite over hypotenuse. The side opposite. There you go. The side opposite theta is 9. The hypotenuse is 41. And make sure, of course, you reduce any fractions or rationalize when you have to. Cosine of theta is cosine of theta is what? What's your adjacent side? 40 over 41. You can either look at the triangle to get tangent, or you can use the fact that sine and cosine have the same denominator. So take their numerators. So tangent of theta, opposite over adjacent. And then, of course, to get cosecant, you flip sine. Make sure that you never, ever confuse cosecant or pair up cosecant and cosine. People always want to do that. It's opposite. Cosecant, sine, secant, cosine. So secant is cosine flipped. And flip tangent and get cotangent. Okay, do y'all have any questions about a problem like that? Okay, the next thing we're gonna look at is special route triangles 30, 60, 90. And one reason I wanted to go over 4.3 before I actually go into 4.1 and 4.2, the unit circle is derived from special right triangle values. So if we're looking at 30, 60, 90, ACT loves to ask questions about special route triangles too. Can anybody tell me what 180 degrees is equal to in radians? Pi. And we're going to talk about that, of course, tomorrow with 4:1, 4:2. But 180 degrees is equal to pi in radians. So in this section for 4.3, you're going to see angles given to you in both forms. 30 degrees in radians is pi over 6. All you have to do to convert from radian measure back to degrees is simply plug in 180 for pi. So if you say 180 divided by 6, of course, that's going to give you 30 degrees. 60 degrees in radians is pi over 3. So they're either going to ask you for the sine of 60 degrees or a sine of pi over 3. So just know that. In a 30, 60, 90, you've got a short leg, a long leg, and of course your hypotenuse. You always want your short leg length first. So in a basic triangle, they're going to let that be 1. The relationship the short leg has to your long leg is the short leg times square root of 3. And that's what this ratio is representing. You've got your short leg times root 3, and then your hypotenuse is always double your short leg. But they're going to give you these values, like they're going to give you this triangle just like that, except for maybe the radian measure, and they're going to say like, what is the cosine or secant, cotangent of 30 degrees? If they ask you for cosecant of pi over 6, pi over 6 is which angle? It's your 30-degree angle. So you're finding cosecant of 30 degrees. But in order to get cosecant, the easiest thing would be for you to find which basic trig function first. Good. So if you find sine of 30 degrees, so tell me what the sine of 30 is. Opposite over hypotenuse. Good, it's 1/2. And then, so that means cosecant of pi over 6 is going to be what? Two. Okay, 45 degrees in radian measure is pi over 4. In a 45, 45, 90 special right triangle, your legs are both the same length. So that means your sine of 45 degrees and your cosine of 45 degrees are going to be the same thing. Yes. Yeah, go ahead. Sorry, I hope you hadn't had your hand up forever because I just now. In your relationship, your legs are the same, so that's easy. And your hypotenuse is always root 2 times your leg length. So let's say that they ask you to find the sine of pi over 4 times the cosine of pi over 4. And of course, it doesn't matter which angle you look at. What is the sine of pi over 4? You got, good, you got 1 over root 2. So, all right, I need to make a point too. When you're finding trig values like this and plugging in, you drop sine. I'll see people a lot of times bring down and say sine of 1 over root 2. Don't do that. Cosine of pi over 4 is going to be the same thing, because if I'm looking at this angle, your adjacent side's 1, hypotenuse root 2. So when you multiply that together, what do you get? Good, you get 1/2. Okay, use your special right triangle values and give tangent of 30 degrees and secant of pi over 4 in exact form. So going back up to your 30, 60, 90, tangent of 30 degrees is opposite over adjacent. So what's the tangent of 30 degrees? Good, it's 1 over square root of 3. But you need to rationalize. So multiply the top and bottom by root 3. So that's going to give you root 3 over 3. Bless you. Okay, secant of pi over 4. Pi over 4 is what angle? What's 1/8? Good, it's 45. 180 divided by 4 is 45. So going back up to your 45, 45, 90, in order to find secant, you need to find which trig function first. What is secant the inverse of? Cosine. Notice here we already found that the cosine of pi over 4 is 1 over root 2. So cosine pi over 4, and of course you don't have to do the step, and if you can just remember find cosine, flip it in your head, that's perfectly fine. So that means secant is root 2 over 1 or root 2. Okay, do y'all have any questions so far? Okay, I want you guys to do this one quickly. This is one of the hardest ones you'll see as far as that, like finding values, plugging in 4.3. Okay, what is the cosine of pi over 3? What angle is pi over 3? What's 180 divided by 3? 60. So cosine of 60 degrees is 1/2. Secant of pi over 3 is simply cosine flipped of, and it's the same angle. So this is going to be 2. Tangent of pi over 3, you should have found √3/1, and then when you flip it to get cotangent, that becomes 1/√3. And I would go ahead and rationalize that. So cotangent of pi over 3 is √3/3. Okay, now that you know those individual values, you can just simply go through and plug them in. So here you're going to have 1/2 for cosine of pi over 3 times 2 for secant of pi over 3 minus √3/3 for cotangent. So that's going to leave you with 1 minus √3/3. And I'm okay if you leave it like that, but MATLAB is probably going to make you go ahead and find a common denominator. And change this, of course, to 3/3, and then finally say 3 minus √3/3. But I'm good if you want to say 1 minus √3/3. Okay, you don't have to write this stuff in purple unless you want to. That's how you find a cofunction value. But all right, cofunction trig values of angles act as complements. So a long time ago in geometry, when you were studying supplementary angles and complementary angles had a sum of what? 90 degrees. So since cofunctions act as complements, that's what you're going to use. You're going to subtract the angle that you're given in your problem from 90 degrees, or if it's in radians, you subtract it from pi over 2. And how you find a cofunction value is really easy. You find what its cofunction partner is, and sine and cosine are partners. Sine and cosine are cofunction partners. Tangent and cotangent are cofunction partners. And secant and cosecant. So sine and cosine, tangent, cotangent, secant, cosecant. So let's say you're given the sine of 30 degrees, and they ask you to find its cofunction value. So sine of 30 degrees, cofunction value, you would subtract 30 degrees from 90 and say cosine of 60. So sine of 30 degrees, its cofunction value would be cosine of 60 degrees. But if you go back and look at your 30, 60, 90 right triangle, you'll see that sine of 30 degrees is 1/2, and the cosine of 60 degrees is also 1/2. So if you're given tangent of an angle and asked to find co-function value, it would be cotangent of whatever 90 minus that angle measure is. Same thing with secant. If you're given secant of an angle, subtract the angle from 90 and put cosecant in front of it. And of course, the same thing if you've got cosine of an angle, subtract it from 90, and sine of that angle would be its co-function value. What if your angle is in radian measure? What will you subtract from? You will subtract from pi over 2. So there's really 6 co-function identities, but if you know which ones match up, sine, cosine, tangent, cotangent, secant, cosecant, you know all 6. Subtract your angle from 90 and put the other tangent function. Okay, you have cosecant of 35 degrees, and you're asked to find its co-function value. What is cosecant's partner? Secant. So I'm going to say secant of 90 minus 35. And of course, you can do that in your head. So it's going to be secant of what? Secant of 55. So subtract the angle from 90, put secant, and you got it. Okay, we have tangent of pi over 7. Find its co-function value. You're going to subtract the angle from what? Subtract from pi over 2. And when you find the common denominator of 14, that's going to give you 7 pi over 14 minus 2 pi over 14. So this is your angle, but what do you put in front of it? What is cotangent's partner? So you're going to say cotangent of 5 pi over 14. If you were to type that in a calculator, tangent of pi over 7, and then type in cotangent of 5 pi over 14, you should get the same value. So that's one way you can check your work if you want to. Okay, last thing we're going to look at. Finding missing sides and angles using trig. Okay, for sides, of course, if you know two sides of a right triangle, you can find the third one using Pythagorean theorem. But in some cases, you may not have but one side length and an angle value inside the triangle. So in that case, you would have to use trig ratios. And if you're finding the missing side, you're going to use trig ratio and regular trig. So in your calculator, you will need a calculator for some of these problems. So you'll use regular trig. On your calculator, you're going to see there's, of course, sine, cosine, tangent, but you will also see that there's sine to the -1, cosine to the -1. Can anybody tell me when you use the sine inverse, cosine inverse? That's for when you're finding missing angles. So the sine to the -1, cosine -1 on your calculator, so on, that's for when you're finding an angle value. Otherwise, you use regular trig for sides. Okay, this particular problem deals with the Washington Monument. It says you are walking towards the Washington Monument and angle of elevation is theta. And so you're standing 1/4 of a mile away, about 1,320 feet. The Washington Monument is 555 feet tall. So they want you to find that missing or that angle of elevation that it makes with the horizontal and side. So what you have to do in this case is determine what trig ratio to use based on what you're given. So always look at the angle and notice that you're given this side, which is opposite that angle, and you're given this side, which is adjacent. So since you have the opposite side and the adjacent side, you need to use what trig function? Tangent. So you go through and set it up. That's what you always figure out first, of course, is which one you're using, sine, cosine, or tangent, and then set up your trig ratio. So tangent of theta, I don't know that angle, so I put theta, of course, that's what you're trying to find, equals your opposite side, 555, over 1,320. Now, in order to find theta, you invert this problem. So this is where the inverse comes in. So you're going to type in tangent of -1 and this divided by that. And that will give you your angle measure. And they tell you to round to the nearest degree. Yeah, go ahead. So theta is approximately 23 degrees. You need to make sure that your calculator is in degree mode. And if you don't know how to do that, let me know. Because it's either probably in radian mode or degree mode. If it's in radian mode, you're going to get a really weird decimal, like point something. All right, last problem. Okay, this problem, this setup deals with a plane rises from takeoff and flies at an angle of 10 degrees with the horizontal runway. When it has gained 500 feet, find the distance of the nearest foot.
At this time, please transition to your second block class.
Hey, I've got your report cards. You can come see me and I'll give you your report card. Regan, here's yours. Oh, okay. Yeah, I gotta do that. Okay, Bill, Jack, Mason, Alex, David. All right, Ryan. Wade, Fletcher. I can do this. Jeremy, Leila, Cassidy Carr, Carson, Kaylin, Chris, Lana.
89. I have an 89, dude.
And here? Is that what you're talking about?
You already called my name.
Are you talking about in here? Yeah. Are you talking about my phone? Okay. Morgan, this morning.
Oh.
It was like an 89 points.
Who's your teacher? She can?
Yeah.
Dang.
All right, Corey.
But I still got a 3.5.
Like some stuff that I posted, like, anyway, like, it didn't save when I posted to them. So yours, like, I fixed that, and that one, I will forgot to do it, 'cause I don't want. But it should, like, when you go check out now, the system's right. This is just not gonna reflect that. Does that make sense? And so. Morning.